Hey everyone, in this video we will be building our model basically. So let's get started with that. So I'm going to say our model, and in the model what we're going to have is I'm going to have a model variable, and I'm going to use models that we had already gotten over here. As you can see on the top, we have already defined models over here. We wanted the model, so we say models dot resnet 18, and you want to say pre-trained equal to true. Why? Because we want the pre-trained model, we don't want to train the model over here. So you can hit shift and enter. This is, don't worry, this is your warning. It's not an error, and you can see the downloading stuff has already happened. 100% of the model has been downloaded. Okay, after this what you are going to do is you have to take the final layer and you have to basically find the number of features. So I'm going to say final layer features first. Let me explain, only then I'll come back to it. Okay, so ResNet model, what happens is, so there are a lot of convolution layers. Okay, and there are many convolution layers like this, and at the end there is a linear layer. Okay, now this as you remember, you can see over here also, it was trained on the ImageNet. Okay, ImageNet 1K. Problem is that ImageNet had 1000 classes at the end. In our, we only have 525, which means this particular last layer is useless. So what we do, we completely throw this particular layer. We don't use it. What we do is the rest of the network will just copy it. Basically, it will be the same. So these things will remain as it is. Okay, we will remain as it is. And instead of this last layer, we are going to have the new layer, and in the last layer, in the last number of neurons will be 525, and in this case it was 1000. Okay, which means this particular last layer is randomly initialized. Okay, randomly initialized, and these layers are pre-trained. However, when we will fine tune, all of these layers right to the end will be tunable, which means they will trainable, rather they will be trainable. Okay, so when we will compute the loss, the back propagation will happen to the first layer. Okay, so that is what we are doing. We are just throwing this last layer because it is 1000 neurons over here. We will not be able to use it, and we are having a totally newly uninitialized layer over here, and after that we will be doing our training. So but what do we need for that? Well, we know what the number of neurons in this layer is, that is 525. How to know what is the number of neurons in this particular layer? Obviously it has to be found out. So in the previous in the downloaded model, okay, that is fully trained model, we will say give me the number of features. So you will say model dot fc, this is the fully connected layer, dot dot in features. Okay, and if you want me to show you why I did that, I can also show you. So what you can do is model, just type model and let it be. Now you go down, completely down, you can see over here in features are 512 and out features are 1000. Okay, we need this 512. How will we know? Because here though we know we don't want 1000, we don't want 1000, we want 525, but there is no way of knowing this directly. Okay, and it depends model to model. So the way we are going to find out is, we are going to say final layer, or what other we can say is final layer in features. So this is our in features. So this is our last layer. This, what to say, this is a variable basically, which will have model dot fc dot, what is the name of this particular I'm sorry, what is the name of this particular variable? It's called in features, right? It's called in features. So I'm going to say in, and you can see this is fc, that's why I've written fc. Okay, why this fc is because here it is fc, every layer has a name over here. And then what you're going to say, features. Okay, this is what we are going to say, and we are going to hit shift and enter. Now what I'm going to do is I'm going to initialize a random layer over here, replace the fully connected this fc layer with a randomly initialized layer. So I'm going to say nn.linear, we are going to use a linear layer, and the in features for that will be final layer in features, right? final layer in features, but the out features is going to be n-train, which in our case, if you remember, is 525. We have already seen over here. N-train is over here. Okay, so that is being used over here, right? And I'm going to hit shift and enter. So this part is done. After that, we need to find the device. So whether we are using CPU or GPU. So for that, you say torch.device, and here you declare if CUDA is available. So for that, you say CUDA, and to find whether CUDA is available or not, we say if torch.CUDA is available, else we use CPU. And then finally we will see what we are using. Since the GPU is not on right now, we are using CPU, but when we will be training the model, we will be using the GPU. Okay, after that we need to have the optimizer and loss function. Okay, so here what we are going to do is, I'm going to say optimizer is going to be torch dot optim dot, as I said, we will be using the Atom optimizer. And what we will be fine tuning, we will be fine tuning the entire model. So I'm going to say model dot parameters. But before that, one thing that I need to do over here is, I'm going to have a new variable, and I'm going to send the model to device. Okay, device. So this device, you know, is CPU, and this particular model dot device is going to send the entire model to the GPU if GPU is enabled. Okay, by default, if we do not write this, even if the GPU is on, it will the model will not go to GPU. But right now, since the model is already on CPU and we are not using GPU, which means it's already on CPU, this function basically won't do anything. Okay, but in case of GPUs, this is needed in order to make sure the model goes on the GPU. So we are going to say model dot parameters. So all of the parameters, including the newly randomly initialized layer, will be fine tuned. So LR, it's the learning rate. Again, this is a hyperparameter that we have already set in the previous video, as you can see over here. So you can see over here, LR is equals to 0.001. Okay, now let's go back over here, and after that, what we are going to do is, we are going to define the loss function as well. So I'm going to say torch, or let's just say nn dot cross entropy, and then you say loss. Okay, and hit shift and enter. You also have to hit this also, shift and enter. So till here, what we have done is, we have defined the optimizer and the loss function. We have, again, right from the start, you can actually go and close this, we don't need it anymore. Okay, so what we have done till now in this particular video is, we have loaded the model, we have downloaded the model over here. You can see the model has been downloaded over here. After that, what we did is, we found how many features are there in the last layer, in the in features in the last layer, and we have replace the FC layer, the trained layer, with an untrained layer, that is nn.linear. And what we have also done is, we have defined whether we have a GPU or not. If we have a GPU, then please use it. Otherwise, over here, if GPU is available, then use it, else continue with the CPU. Finally, we have sent the model to the GPU, and lastly, we have defined the optimizer and the loss function as well. So I hope you in the next video, we'll be writing the train function and the validation function, and finally we'll be training it. So yeah, if you like the video, please like and subscribe. Thank you very much, and bye.